Understanding the role of ports in TCP traffic is important when configuring network settings on your computer and when troubleshooting network problems that might arise. So here we're going to look at a simple scenario where packets are traveling from a client computer through firewalls and to web and post office services. So we've got a couple computers here, and we're going to call one of the computers John, and that simply represents a port number like 142.23. So I'll just make up some type of address here, and it's going to Fred, so I'm just going to use John and Fred instead of an IP address. Port numbers represent where the packets are coming from, what applications they're coming from, and what they're going to. Well-known port numbers like 80 and 110 are standardized, and port 80 represents an HTTP protocol, which is used by web services. Port 110 is used by POP services. Now, typically when a packet goes out, it has a IP address and it has a port number attached to it. Together, this is called a socket, and you need both for communications, and we're going to show why we need both. We're going to represent this instead of using numbers. We're just going to indicate the IP address of where it's going to, and we're going to represent the service that it's going to in a packet. So this would be the addressing we're going to use. So the IP address is used to identify what computer we're sending to or from, and the port represents what application or service we're sending to and from. So let's take a look at how this works. So John has opened a Chrome browser and a mail application, and wants to retrieve a web page from Fred, the server. So one of the first things that has to happen is the Chrome browser is going to make a request, and what we have are two firewalls in between here. Now, by default, firewalls are generally configured to allow outgoing traffic. You can configure firewalls to block it, but generally they're going to let traffic go out through a computer because the firewall is assuming you want traffic to go out. When you have set up on a server, when you set up a service like a web service, you need to make sure that traffic coming into the firewall is allowed through. So a web service is going to open up what are called ports or holes through the firewall. So a web service that uses HTTP or port 80 is going to allow traffic coming in that has a designated port address of 80. And the post office is using the POP protocol or 110, so it's going to open up another port through here. So here we've opened up two ports through our firewall. You need to maybe do that manually in manual firewall configuration, but often when you install these services, they open up those ports automatically. So we're going to go back to John here, and John is going to create a packet, and as part of the packet, the addressing is the first part of the information. So we've got a to field and a from field where this packet is going to and who it's coming from. So we're sending this packet to Fred, the server, and we're sending it to the web service, and that's the well-known port 80 or HTTP. So that addressing information goes at the front of the packet, and it's coming from John. And the port we're coming from is not a well-known port. It's an application, so generally applications just pick a random port that's not being used above 1,000. So we're just going to pick 1,000. Now it's important that we have a port that we're coming from, because when traffic comes back, we're going to use that number to find out which application we're going to send the return information to. So eventually this is going to get return information, and it needs to know, the computer needs to know, should I send this to the mail app which is open, or should I send it to the browser app which is open? So that traffic is going to go out through the computer, and it's going to go through my firewall, which allows everything to go out. It's going to be carried through my internet here, and it's going to hit this firewall. Now at this point, this traffic is called unsolicited traffic. And it's unsolicited because Fred did not know this traffic was going to happen. However, so the firewall inside Fred looks and says, okay, it's addressed to Fred, that's fine. And it's using HTTP. Well, that's one of the things I allow, so it comes in through the firewall and it uses the information in the port HTTP to say, that's for the web server, so I'm going to direct it to that piece of software there. Now Fred processes that. It's an request for a web page, and so Fred is going to generate a return packet with the information in it. Okay, and as far as the to field of the packet that's generated, it's going to go to John because this came from John. And it's going to go to port 1000 because that's the application that requested this information. It's coming from Fred, and it's coming from HTTP. And then in the rest of the packet is actually the data, the information which is being requested, which would be the web pages and the graphics and all that information. So that traffic is going to go out through my firewall because my firewall allows everything to go out. It comes here and now it hits this firewall. Now at this point the firewall inspects it and says, this is now solicited traffic because John sent a request out earlier to Fred from port 1000, and now this is the traffic back to John using that same port 1000. So this firewall allows this traffic to come through because it's solicited. We generally do not need a firewall rule to allow solicited traffic back in. In fact, we would need a special rule if we don't want it back in, but generally that's not the case. This computer then looks at that packet and says, this is going to port 1000. Well, I know that Chrome generated earlier packets from port 1000, so it knows to send it to the Chrome browser as opposed to the email application. Now later, pick another color here, our email application is going to do the same thing. John is going to request to retrieve some emails. So the mail is going to generate a packet out through the firewall. It's going to go through Fred, but now the protocol is POP, actually POP3, because POP3 is the current level of that POP standard, port 110. From John, but now it uses a different port number. I'll just pick a random one, and using the POP protocol, and protocol just means rules, there are some instructions in here basically saying I want to get stuff from this mailbox in my post office box. So this gets carried out again through the internet. It hits the firewall as unsolicited traffic. However, doesn't come in through the firewall through the port 80 that's open, but it comes through the POP because POP also has an open port, and it comes through here, and because it's using port 110, the POP port, it gets delivered to the post office. The post office retrieves the mail, sends it back to John on port 1100 because that's where the from information was from in the originating request. Goes out through here, hits the firewall, again solicited traffic. It's using port 1100, which was generated by mail, and comes back through here. Because these two ports are open over here, we call this the web service is actually listening on port 80. So sometimes you'll hear these terms used. or it's listening on the HTTP port. So we have a firewall over here. It has two ports which are called open, and there are two services which are listening on those ports. The web service is listening on port 80, and the post office is listening on port 110, or the POP port. So that's a little bit how ports and TCP addresses are used together to send information from applications through the internet to another computer, to a service, and then back again.